Hey everybody, yeah, thanks Jim. My name's Andrew. I'm going to talk a little bit about detecting flaky tests, increasing trust in your test suite. A little bit of background on this. This is a Ruby app that had some testing issues. A lot of those had to deal with process problems. I like to solve problems in code, and so one day I got really frustrated, asked my senior architect if I could spin up a DigitalOcean database to start tracking some test data, where things were flaking, all that sort of stuff. Short answer was no, long answer was yes, but you have to pay more money to an approved vendor. That's how this got started. Flaky tests, this is how I define them. They're tests that produce inconsistent results. In other words, they fail sometimes when they shouldn't, without changes to the code underneath. So, if you've ever, say, tried to push code on a Friday, the test suite fails, and your senior engineer says to you, hey, just run it again. That test fails all the time. You have flaky tests. Non-deterministic failures, they fail for seemingly no reason. You run them on the same code over and over again, no matter what you do, and they're generally hard to reproduce. It could be the particular seed that was run. In my experience, it's generally some global environmental state that causes the problems. And the main problem with flaky tests is they undermine confidence in your test suite. The other developers on your team no longer know that red means red, and it fails. It's now red means try again. That wastes time, money, resources, GitHub Action credits if you've paid for those. A lot of times the solution is, just rerun it, it'll be fine. Every developer, when you're trying to ship on a Friday. But ignoring them only makes them worse because you keep adding more and you may not realize it. There's usually caused by these race conditions, poorly controlled test data. Maybe you're seeding some data randomly and that maybe causes it to fail. A lot of times test order is a good one. If you have some global state, Ruby has a concept where you can access thread matter. It's basically, I'm going to put this on the process where Ruby is currently running, and then I want to access that variable later, regardless of where I am in my code. If you do that in a test and you're running in the same process, one test sets some state, another test either correctly or incorrectly assumes that state is either there or not there and flakes when the tests are run out of order. So RSpec and Ruby will randomize your tests for this purpose for catching these. So, how do you catch them? How do you figure out where they're coming from? What I'm going to talk about is from GitHub's method. This is a link to GitHub's blog post on detecting them and what to do about them. It's heavily inspired this talk and what I did in Ruby. Some key points. You're not trying to get them all. You're trying to get about 90%. If you can catch 90% of your flaky tests, then when it is Friday and it is time to ship code, and maybe your test suite takes 10 minutes to run, a lot of times that can be easier. And you can just rerun stuff. But you've caught all the nasty bits, and maybe you caught that 1 in a million. What you're going to do is run your failing tests multiple times in different scenarios. In RSpec, we have the concept of RSpec retry, which you can set as an environment variable, as a flag when you run RSpec. And you can say, if a test fails, rerun it 3, 5, 10 times. In this, we'd set up an environment, in CI, and we'd say, all right, if this fails, rerun it 10 times. If any one of those passes, we now know we have a flaky test. So we can store the results for later analysis. Another one would be like shifted in time. A lot of times if you're running reports at the end of a month, maybe your test assumes that it's not the end of the month, or maybe it's not the first of the month. And your test says, hey, insert some data 2 days ago, and then it expects that data to show up in the monthly report when the month just started that day. And then the last sort of most expensive, most time-consuming, but can be helpful for those trickier cases is running in an isolated run. Ideally, you would spin up a whole new GitHub Actions and run just one test that failed, check the result, and report back. In my particular example, when we did this, it was just the sub-process. and we would have basically RSpec wait, we'd spin up a sub-process, rerun RSpec within RSpec, and see if it passed, and occasionally it would. And then now that you've got your flaky test, you can do something with the data. So the last step there was to make sure that you store your data. So what you're gonna do is pass the test so it doesn't fail the whole suite. You now know it's flaky. That means it's meaningless to you. It doesn't matter if it passes or fails. Every failure, you don't know if it actually failed or if it's flaky. Report it somewhere. GitHub Actions has a really cool feature where you can push into an environment variable with some markdown, and when it completes, you can render tables and everything in it. You can oh, this test failed, and this was the seed, and all that. You can also do things like automatically take action. So, for example, after you build up this data for a while, you could say, you know, this test now fails 30% of the time. Maybe that's our threshold. Somebody, you know, open a ticket and assign it to a developer. We're going to take care of it so that this doesn't happen, because as you get more and more, if one happens 30% of the time, another one happens 30% of the time, another one happens 30% of the time, you're now up to 90% of the time your test suite fails for no reason. And then you're going to want to log some additional metadata as these fail. This includes things like the test name, some universal identifier if your test suite supports it so that it doesn't fail. RSpec has a concept of basically ordered IDs, so you can get around if you name your test and all that. You know, run ID, seed, anything that's going to help you figure it out later, including why it failed. So when you use your data, you can then figure out when it first flaked, why it's flaky, random time, global state, how frequently does it fail. You can even get real fun and see with the GitHub run IDs which developer is getting the short end of the stick with flaky tests. You can say, oh, who's most affected by this? I know in this particular example, for whatever reason, I was always 100%. I think that's because I was always fixing them. But if you looked up, you'd see my username, you know, flakes 100% of the time. So doing this, you can increase trust in your test suite. It means red, and it will reduce build time overall, especially if you've increased the build time to try and detect flaky tests. If you get rid of them, it reduces it. So flaky tests, you rated trust. If you can do it systematically, automatically, it doesn't take a developer to do it, and you can increase confidence in your test suite, and you can fix the root cause. I left this in for any questions. I don't know that we have time. I think everyone wants to socialize and drink some beer. But if you want to talk to me after this about anything, I like homebrewing, coffee, chess, hydroponics, of course, coding and all that, and then that's my GitHub. Thanks, everybody.